whether side-side angle is ever valid for triangles. Here we have, if we have a side angle side between two triangles like this, we know that that's a way to prove that two triangles are congruent. All of these ways, side, 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 angle, side, angle, side, angle, side, and angle, angle, side, are all going to work. Now we have side, side, angle, which is also called angle, side, side. And people, students, and others who use that criterion might be thought of as being donkeys. And here's the reason why that doesn't always work. Side, side, angle. We have this exhibit here, exhibit where we have side, side, angle in the triangle on the left, and that's going to have angle, side, side in common with the big triangle ABC. But even though side, side, angle holds, we know the triangle ABD is not going to be congruent to triangle ABC. Now, here's another example of why this may fail. This is going to fail here. What about here? Here we have an isosceles triangle, ABC, so base angles are going to be congruent. Base angles of an isosceles triangle are congruent. Now we have angle side side and angle side side, and we have triangle ABD, and then we have triangle CBD. But it's plain to see that the triangle on the left is not congruent to the triangle on the right, even though angle side side and angle side side correspond. So that's a case when angle A is an acute angle. We can come up with examples where the diagrams show us that this criterion SSA fails. Now we go to the next case. Our next case would be that angle A is a right angle. Now, an angle A is a right angle. Okay, here we have angle A is a right angle. We have angle side, side. Well, if you have two right triangles and we have a leg and a hypotenuse in common with another right triangle with a leg and a hypotenuse, we have it's hypotenuse leg, and hypotenuse leg is valid, is a way of proving triangles congruent, because the third side of these two triangles has to be congruent. Third sides have to be congruent by the proof of that. The proof of that, okay, the proof of that is by the Pythagorean theorem. If you have hypotenuse and leg, you're going to get the other one because a squared plus b squared equals c squared. And so side b here is the square root of a squared minus c squared. Or you have, in most general, so any leg is going to be determined by the Pythagorean theorem. So in case 2, when angle A is a right angle, this is SSA is good because it's hypotenuse leg. When we have a right triangle. Now, we're having some technical difficulties, but we'll move on to the third case, to our third case. And our third case is going to be the third case is going to be when angle A is obtuse. So we have this situation. Here's angle A, and here's the side. Now, this is going to be vertex B. So what we want to establish is where is C going to be located? Well, C is going to be over here somewhere. How do I know that? Well, you're going to have vertex C is on half line AC. It's going to be on half line AC, on the right half line AC. That's because the only other option would be to have C somewhere here on the left half line AC prime, somewhere out there. But then angle A would be acute, but that's a contradiction because this case A is obtuse. So we can't have A out here on the left. So another thing that has to happen is that AB has to be less than BC. Otherwise, we don't have a triangle either, because if AB is equal to BC, there's going to be just a straight line there. And if AB is greater than BC, and BC is smaller than AB, meaning then you're not going to reach the base where they have the obtuse angle. So you'll have to have these two conditions if A is obtuse. So that means triangle ABC is completely determined. And if you have a correspondence in this way, where you know angle A and the other angle in the other triangle, when you know that in the other triangle, when you know that these angles correspond and these sides correspond and the angles are obtuse, this congruence is valid because there's no ambiguity there. And so what I've shown is that SSA is valid when angle A is obtuse. Don't forget to hit like and subscribe if you want to see more content. And so that's the end of this presentation.